chemical bonds, keeping our molecules together. The world, as we know, it depends on the fact that, for the most part, matter sticks together. It doesn't disintegrate or fly apart. For this, we could thank the force known as the chemical bond. Chemical bonds form when two or more molecules come together to share or transfer their electrons. When they do, an entirely new chemical substance or molecule is formed. A molecule is simply a group of atoms bound chemically together. Importantly, the molecule produced by chemical bonding can have qualities quite unlike the separate atoms or smaller molecules that come together to create it. For example, when oxygen and hydrogen bond, we get water. Oxygen is the gas we all know and that we all breathe. Hydrogen, on the other hand, is a gas that caused the Hindenburg to explode, the giant airship filled with hydrogen. Hydrogen, when it reacts with oxygen, will release a tremendous amount of energy, an explosion, but will become water. And water is a very helpful liquid that we all drink. So first, to understand this, it's recommended that you understand the atomic structure, or if you don't understand that, you can watch my other video called Atoms, which will be extremely helpful if you want to understand this video. So, electron shells. The electrons in an atom reside in electron shells around the nucleus. So, for example, hydrogen has one shell containing one electron. Each shell can only contain a limited number of electrons. In the first shell, you can have a maximum of 2. Shell 2 can hold up to 8. Shell 3, you can hold 18. Shell 4, 32. Shell 5, 50. Shell 6, 72. And shell 7, 98 electrons. But the shells aren't always filled to capacity. So the electrons in the outer shell are called valence electrons. Those electrons are the most important electrons that take place in most of the chemical reactions. All elements seek to fill their outer shell to capacity, because filling their outer shell to capacity is the most stable electron form. That can mean losing the valence electrons or gaining them. For example, we have sodium on the bottom left. If you look at the outer shell, there's only one electron. So to reach the more stable state, they would want to lose that one electron. So if you lose that one electron, it'll be more stabler, and the sodium will be a positive ion because there are more protons than electrons since you just lost an electron. So it'll be a positive ion. On the bottom right corner, we have iodine. Iodine, if you look at the outer shell, there are 7 electrons. They would want to gain an electron to form a more stable form of 8 electrons. And now we have different kinds of chemical bonding. Ionic bonding and covalent bonding. So first we have ionic bonding. Ionic bonding is when one atom takes some electrons from the other atom. So one atom will have a negative charge and the other will have a positive charge. Positive charges attract negative charges, so the ionic compound is formed. In the animated diagram on the right of that paragraph, we see, we see that sodium outer electron is being transferred to the fluorine. So the sodium lost an electron to reach a more stable state. The fluorine has gained an electron to reach a more stable state. And now we have a positive charge and negative charge, and they attract, forming the compound known as salt. Now, covalent bonding. Covalent bonding is when atoms share electrons. When two or more atoms join together with a covalent bond, a molecule is formed. In the animated diagrams, we can see, for example, the two hydrogen atoms. They join together to share their two electrons, the top left one, to become the hydrogen molecule, two hydrogen atoms. Now on the bottom left, we see one carbon atom and four hydrogen atoms. They share the electrons, so the carbon will have a stable 8 valence electrons, and the hydrogen will have a stable 2 electrons because they're sharing it. And it forms methane and other bonds. And we have polar bonds. Polar bonds are interesting. So in a covalent bond, sometimes one atom will have a greater electron pull. So they're going to kind of hog the electrons. They're still sharing them, but the electrons are mostly with that more electron pull, the atom with the more electron pull. So on the picture on the right, we have water. Water is actually a polar molecule, which means there's like a poles to it. So there's like a positive pole and a negative pole. Now the reason for that is you could see the two black dots, and those are the electrons. Notice that they're closer to the oxygen atom than the hydrogen atom because it has a greater electron pull. So it's gonna have a more negative charge because it's hogging the electrons. Now the positive sides of the molecule are the hydrogen atoms. The hydrogen atoms don't really get their fair share, so they're going to be more positive. And the interesting thing about polar bonds is that polar molecules will have attractions for each other because of the poles, like magnets. Think about a bunch of magnets. They're going to have attractions for each other because they have these positive, negative poles. For magnets, that'll be north and south. These are electrons. The electrons form an electrical charge. A hydrogen bond. Now, so with my example of water, the slightly positive hydrogen ends of the molecules tend to attract the slightly negative ends of their neighbors. So this attraction is hydrogen bonding. So the hydrogen atoms are attracting the more positive hydrogen atoms are attracting the more negative oxygen atoms. So this hydrogen bond is a very weak chemical bond, similar to ionic compounds, but not nearly as strong. And now metallic bonding. In pure metals, many metals have relatively few valence electrons, like 1 or 2. So as a result, these electrons tend to be easily removed. In fact, they tend to wander about the atoms of solid metal. So to picture this, you could picture a bunch of positive metal nucleuses in a sea of electrons. So their own electrons are kind of wandering around. So they're sitting in a sea of electrons. So these electrons can flow freely between and around these positive charge islands. Now, they can flow freely, which also explains why metals conduct electricity well, because the sea of electrons, electricity will be able to flow much easier because they're kind of freely wandering. And it also explains why pure metals can be easily bent, shaped, molded, and cast, because the individual metal atoms floating loosely in their sea of electrons can be pushed about. This is why most metals are malleable